Hey y'all, CJ Burke here with DevelopEV, and today we're going to be talking about all the reasons that charging stations can fail. All right, so we got Drew.HasBrouck here, and we're going to talk about all the things and all the reasons why EV charging stations can fail. If you're an EV driver, you've probably seen in the news things in Chicago about charging stations failing, or you've experienced yourself going to an EV charging station and not having it work as intended. And we're going to talk about all the reasons why. So we got Drew.HasBrouck here. We actually worked together previously at in the consulting space. So you're going to see a lot of consulting-esque things today because that's what we are both very good at. Drew, do you want to do a quick intro?
Sure. Hi, everyone. And CJ, thanks for having me here on the show. Drew.HasBrouck, I'm a consultant at PA Consulting, focused in the clean and smart mobility space. I have already gotten 2 fast charging stops in this morning and done a little bit of reliability scouting in the wild. So we work with fleets, utilities, and investors, but we're drivers out there with you too, and excited to talk about some of the reliability issues we see today.
Awesome. No, Drew, thanks for being here. And I think, both of us being EV drivers ourselves and kind of experiencing these things, like I've spent a night in my car because a DC fast charging station didn't work. So it's important that us in the space not just talk about these things and help our clients with them, but also like actually drive the cars themselves so we're not hypocrites. All right, so what we'll talk about today are kind of 8 different things that kind of both of us think are reasons why EV charging stations in the wild can fail. And there's probably a lot of different things that we could touch on, but we try to kind of consolidate them into kind of the key things that we think cause these stations to fail. And a lot of you may have experienced these, and some of these may be things that you might not have heard of before, but are very important to keep in mind, especially if you're actually out there building these things, because they might be things that you might not hear of or consider depending on your own experiences and where you are in the parts of the country. All right, so first thing we'll talk about is the external telecom networks. Drew, do you just want to give a quick overview of what this is and kind of how they can fail?
Sure. So this one's a bit that's probably quite understandable by most everyone in the audience here, because we all have this experience with our cell phones at one time or another, unrelated to EV charging. So when we talk about external telecom in the context of public fast charging in particular, normally we're talking about both the signal from the telecom provider to the charging station itself, and also the signal to you, the driver, the fleet operator, whomever, the user that needs to authenticate a charging session.
Yep. And, there's a lot of things that can go wrong, whether, just as you touched on, it could be the charging station itself, or it could be the actual telecom network, AT&T, Verizon, T-Mobile, depending on if there's an outage on their network, right? They could have a tower that's down for maintenance. Could be a big storm that knocked out power that didn't affect your charging station. Like you could have power at your DC fast charger, but 3 miles away at that tower, they could have lost power and there's no diesel generator to back it up or solar storage or whatever. So that's kind of one thing to kind of keep in mind. But then also on the charger, right, it could have a bad modem. It could have, and that's one of the things I see fail a lot that I have to deal with is that there's a bad modem, a bad SIM card, something happens in the internals of the charging station that they don't communicate back to those networks properly. So when we're talking about ways to solve this, one things I've had experience with is when you're walking sites to actually evaluate EV charging infrastructure is actually taking, I call them squids. It's basically a way to analyze the cell strength in a certain area. And, it might kind of seem like overkill, like if you're doing and install in like a major city, you're like, well, why do I need to test this? Like my cell phone works just fine. But there can actually be little dead zones in little pockets, depending on how the signal's bouncing off of buildings, that can really cause a lot of issues for getting a good, strong signal to your charging station, especially if you're like in a parking garage. It's like the worst case scenario. And that's something that I think most people experience too. Like if you have your cell phone, you're on the 4th floor of a, large parking garage in the basement, you're probably not going to be able to, send a text message or check your social media, right? And there's no chance that an EV charging station is going to be able to get that signal out to authenticate your EV charging session. So definitely check before you go. I've also seen some solutions out there for dual SIMs, right? So you have two networks, right? So there's like a primary and a failback. So like, if you're like primarily Verizon, your fallback's AT&T. It's like the same stuff if you've ever gone camping in like a big RV van, right? They usually have for like local Wi-Fi on your RV or your trailer that you can have, I think, up to 3 or 4 SIMs on there. So you can always get really good Wi-Fi when you're traveling.
Yeah, and I would just add to that, CJ, to double down on the garage example. This is causing consternation for many in the industry, particularly as we're starting to see large-scale level 2 charger rollouts, multi-unit dwellings, parking garages in cities. The connectivity to those chargers is just a tricky thing to do and needs to be done well. Otherwise, the users are going to have a lot of problems. And one thing that we've seen is that, particularly in garages, in some cases, a publicly accessible Wi-Fi network is also put up in parallel with the communications to the chargers, because people don't have cell service and they need cell service to authenticate these transactions. So it could be a multifaceted solution, but absolutely needs to be tested and understood.
Yeah, and to go along with that, I think one thing we've seen too from at least the network side is actually having cell carrier boosters installed alongside your charging installation. It's easier when you have level 2 charging because a lot of those boosters work off of 208 or 240. But when you have like everything's 480, like a large DC fast charging installations, a lot of those boosters, I haven't seen them go off at 277, like a single leg off the 480. Which causes issues because then like, well, do I need to put a whole step down transformer, a low voltage panel just for this booster? So it's stuff you definitely want to get on the front end, get ahead of it as much as possible to understand those constraints. Because as we start to extend mobility solutions out to the larger public and to people that don't have garages, that are going to be in apartment complexes, that are going to be in these large cities or other places that there's going to be a lot of level 2 charging. It's going to be very important that we address these really head on, right? But before you're commissioning and you're like, I actually can't commission this charger because it actually can't get a signal to it. All right, so next we'll talk about the software network itself. So Drew, do you just want to talk a little bit at a high level, like what are these software networks and kind of what's their impact?
Sure. So in general here, we're talking about the network that's put up by the charge point operator. So the EVgo, the EA, the Blink, whomever is providing the network. And it may actually be provided by those CPOs that we know the names of, or it may be provided by carriers in the background. But in either case, there's a network that manages these chargers that does a whole bunch of different functions behind the scenes to make charging sessions run smoothly. And that network needs to be up and running to be able to provide that service to the chargers. And I think the thing we'll talk about here is there's sometimes when those networks do not have as reliable performance as we'd like, and we see them go down. That there's been multiple instances of that in the last couple of years across major networks here in the U.S. And I think CJ's also got some horror stories, perhaps, about incomplete commissioning in particular.
Yes,
with regard to these networks.
Yeah, and I'll just pull up a quick kind of screenshot you took from Twitter here, where this is from Blink, and this is December 8th, 2023, where they're basically saying, hey, sorry, we're working hard to get our network back online. And key point here, get all chargers back online. So this is the situation where an entire network of charging stations went down. So, if you're putting this into more of like a conventional fuel concept, like imagine if like all of Chevron's gas stations like just were like, oh, sorry, can't serve you today. Like that would be pretty unfathomable, and that would probably be like on every major news network. But this is something as EV charging becomes more and more the primary source for people to fuel their vehicles. Like this stuff has to be, I'm not saying like data center level of reliability, not like Six Sigma with like however many nines behind the decimal point, but has to be pretty up there that things like this can't take down a whole entire network. And sometimes this is out of their control. This could be due to like Amazon Web Services or Microsoft Azure, Google's cloud having issues that's actually hosting these CPO networks virtually on their clouds. But at the same time, they have to do a better job of kind of understanding that if they take down a whole network, that's like, that's a significant issue. I think also ABB had a similar one back in September of 2023, where like all their chargers went down mysteriously. And one thing I think from a CPO standpoint, I think most people, at least some of the CPOs have this understanding, but like if your network goes down, go to free vend, right? And free vend is, hey, you can sell all the power you want, but you can't necessarily collect back on that income during those times when your network's down. And I think that's a prerequisite. I've seen that in certain incentive programs. They call that out specifically. If your network goes down, you have to default back to free vend because no one wants to sell things for free. At the same time, you can't have drivers that are sitting waiting at potentially, at least currently in this day and age in 2024, that maybe the only charging station that can get you from point A to point B between two major cities, which is, currently where we're at. Once there's more competition, this won't be as much of an issue, but for the probably medium term here in North America, this is going to be a big problem.
That's right. Yeah. And free vend is really a good solution for a couple of reasons. One, it promotes that user experience, that driver experience that needs to be there to build confidence in the industry, individual networks aside, really. And the other is that it obviously puts a little bit of an incentive for the network to figure out how to solve their problem because they are losing dollars directly during the period where they're having the issue. So I really like that alignment of incentives. The other one that we'll just talk about briefly here is software updates on these networks that have bad coordination. Mm-hmm. And, I personally had an example of this come up in the last few months or so, where a network was switching over from one software vendor to another, right? So nothing happens to the chargers, nothing happens to the name of the station, but the network behind it, so something that's barely visible to the consumer was being swapped. And while that seems like it should be a seamless thing, it is far from it, I think, in most practical situations. And this particular network had managed to attempt this cutover at the same time across all of their sites in a region, which, as you might imagine, essentially means that if you're the driver, you pull up and that site doesn't work. The next one 15 miles down the road, oh, by the way, same issue. So that's a big problem, and we just need to do better in that regard.
Yeah, absolutely. It's almost crazy that they don't think about those things when they're making those cutovers. I'm assuming that they're testing this cutover in a lab, so they have probably like a dummy station that they're saying, okay, it doesn't look like there's any like critical bugs that are just going to completely brick this. But that also has been the case in the past, so I'm not going to put it past them. But knowing that if you take out a whole region or a section of chargers, that's going to have, especially if you're like the sole supplier of DC fast charging in a region, which is pretty much currently Electrify America, but others too in certain areas of the country, that if you take out that route, you're basically taking out any mobility options in those areas for anyone. So you have to be very strategic about that, very, picking and choosing how you're making that update that doesn't prevent people from actually using your network and getting across the country. And I think the more people in these companies drive electric vehicles and actually go on these trips, they'll understand this. But I almost kind of wish that there was a way that they just don't do this in the future. And I think they've gotten enough bad flack. And I've seen it in YouTube. I've seen some articles out about it, some posts on LinkedIn, but I haven't seen it really in the mainstream media yet, where people are kind of saying like, "Hey, we're trying to go from point A to point B, and Electrify America took out their whole network in this area to do a software update." And then I think another thing I want to touch on is commissioning. So that's where you're basically, everything's done with construction, the charger's in the ground, everything's looking good, and you're actually just making that handshake connection with the cloud network to make sure that the charger is actually able to authenticate transactions with the customer to get the charging station going. And sometimes I've seen that being done by It could be an electrician in the area that isn't necessarily as tech savvy or isn't really as good with a laptop. And that's nothing against them. It's just sometimes what happens with certain trades, that these are kind of partially commissioned, or maybe a couple stations within an array of chargers are commissioned. And some very excited EV drivers might have been watching this charging array get put in at their workplace, or a key corridor that they need to get from point A to point B on a trip, and they go there and there's maybe one charger working or kind of working, or a reduced power output, that if the charging station is properly commissioned in a timely fashion and is properly communicated to their network, that it helps to avoid some of these issues. Next, we'll talk about interoperability. This is kind of sounds like a buzzword that is used in the EV charging software space, but Drew, do you just want to give us a high-level overview of what interoperability is and why it's important?
Sure. So as CJ alluded to, there's a lot of depth to this topic, but I'll keep it brief. When we talk about interoperability, what we're fundamentally talking about is the vehicle and the charger being able to communicate and being able to deliver a successful charge in unison. And there are communications that need to go both ways. The vehicle telling the charger what it needs, the charger communicating to the vehicle what it can provide. There's a whole series of data flows that need to happen. And if there's any challenges there, for safety and other reasons, the result will be a charging session, either not being initiated or being interrupted. And that can be quite frustrating when everything else in the suite of things that could go wrong has gone right for you in your charging situation.
Yep. And this is something that's very upfront to the customer, because, you could be trying to plug in your brand new car that you got, let's say it's like a VinFast or something. It's like a newer car to the North American market. And you're charging on this DC fast charger next to your house, and you're all excited to charge it for the first time, and it's just not working. And you don't know why. Usually when these errors happen, either pops up an error code on the screen, which is essentially gibberish to, I would say, the general public, right? They're not going to know what error code 1542 means on a screen, right? That provides the customer nothing. Or it basically is pointing back to the car saying, hey, your car has got an issue, right? And it's like, well, I just bought the thing, what's wrong with my car? So I think there has to be a lot of work done before cars and DC fast chargers hit the market, that there's a lot of interoperability testing that's done behind the scenes with the vehicle OEMs, the charger OEMs, so that they know that they're going to work on majority of, for most cases, light duty vehicles, right? That's when we're talking about public charging stuff, but I guess also for fleet charging too. This is something I deal with a lot, actually, on a daily basis, is that a lot of these large truck OEMs aren't as savvy as the light duty vehicle OEMs, and they're not actually doing that interoperability testing. And the OEMs for the chargers too are kind of they're very focused on light duty, but they haven't touched as much the heavy duty, and it's not something that I think the customer has to deal with, right? They shouldn't have to be calling Electrify America or EVgo and be like, hey, I'm about to take a road trip. Have you done interoperability testing with a VinFast car before, or the new Porsche Taycan or whatever? It's not the customer's job, and I think it's really a responsibility of OEMs on both sides of the charger and the vehicle to really nail this stuff to make sure it works before it's out in the market.
Yeah, that's absolutely right, and I think hopefully medium duty vehicles will fall closer to light duty as far as the testing standards, just because of their greater similarity in vehicle type and who's making them. But for the heavy duty vehicles, it is an interesting challenge because a lot of those will be depot based and in more closed loop environments where interoperability with random or quasi-random chargers is less critical. And so you can see where it falls down the priority list potentially, even if it is thought about by these players. But it's something that needs to get solved, and obviously needs to get addressed to let large EV charging hubs, whether that's for, let's say, drayage, heavy duty, to take off, or as you start to see, corridor heavy duty trucking.
Absolutely. And if a lot of these chargers behind the fence, are free vent, it really doesn't present to me issues. But anytime you start to do like time charging or time of use or responding to demand response events, you kind of have to have that interoperability testing so that the vehicle doesn't freak out when there's reduced output coming from the charger, or it's going to come on in 4 hours. So it's important that those kind of handshakes happen. And one thing I have found out is that, there are, set standards through OCPP and other standards organizations for these communications to happen. So as long as everyone's following the standard, theoretically, right, there shouldn't be any issue. But what I have found is that sometimes people in different countries actually read things differently. They have different interpretations of how it's written. So there's a bit of a language barrier sometimes. And then also it is kind of written in a very ambiguous way, so that people can take different opinions on it. Even if they read it the same way, they could do a completely different avenue. So it's important that you kind of go through a checklist process just to make sure that those signals are being interpreted, going through those OCPP logs and making sure that things are being, the charger and the vehicle are responding in the way that you want them to be. And there's no kind of hidden bugs in there that, 9 times out of 10 is going to work, but maybe that 1 out of 10 time isn't going to work if there's a finicky system or something else happens as well. So it's important to kind of get that from the whole customer experience standpoint. Next, we'll talk about hardware. And this probably makes the most sense. It's probably, not the, craziest techie thing, but Drew, do you just want to give a high level overview of the hardware and generally why they fail sometimes?
Sure. So there's, as you might imagine, several categories within our broad hardware bucket. Several of these are quite visible to the user. Some are not as much. But I'll start with those that are quite visible to the driver or fleet user or whomever else is actually interacting with the charging equipment. Kind of top of that list are screens and credit card readers for public-facing charging. Also in there are cables and cable management, right? So just ticking through those for a second. Screens. I think we've all experienced this in some shape or form in our lives. Screens don't hold up to whatever conditions we figure out how to throw at them sometimes, and that's just a reality. So you'll see, cracked or damaged or just fully blacked out screens, and that can be an issue. We'll talk about how big of an issue that is or is not, perhaps in a minute, but that's kind of the signs you'll see. Credit card readers, CJ can go deep into this issue, but ultimately this is usually a connectivity issue, not usually a mechanical issue with the hardware, although that is possible. On cables, so we see cable connectors damaged. I think that's relatively common. You'll see, you can walk around a fast charging site and see different cable connectors, different colored handles is often the giveaway there. So that is a part that gets replaced. The actual cable itself can also have damage. That's probably a little bit less common, but possible and might be observable by an everyday user. And then cable management solutions. So this is relevant for both fast charging and level 2. Oftentimes the level 2 cables are a little longer, so it becomes more of an issue. But this is more about keeping a tidy site and frankly avoiding the damage to the cable and cable connector that might come with not having the cable management solution in place. The last two that I'll just hit on very briefly are less visible to the user, and that's switchgear and other electrical equipment on the site. There can be issues there. That's apparent to the people operating the site, people installing and commissioning the site. That will not be apparent to you as a user. And the other one is really fundamentally the power modules, the power electronics that are the heart and soul of the DC fast charger. Those can fail. Thankfully, most units are modular in nature, so the typical result here is a derating of a charger, not getting the output you're expecting rather than a charger fully offline. But that does vary by the make and architecture of the charger. So I'll pause there, CJ.
Yeah, no, I think that was an awesome overview. And yeah, there's stuff that the customer's not going to see, and there's the stuff that the customer sees. And I think the most obvious is that cable, right? Because, regardless of, the truck or the type of car, they're going to have to touch the cable. And since that is going to be out in the public or even behind a fence, if you're a fleet, someone's going to be interacting with that. A human being that is capable of error is going to be interacting with that piece of equipment. And especially with DC fast charging, that's very cumbersome. It can be very difficult. Even me, I'm 200 pounds. I can definitely maneuver the cable, but it is very challenging, especially if it's colder out, to actually get that to connect into your car. And since they are out in the open, they are open to vandalism. Someone can just kind of knock it off the holster. It can get run over. The cable management itself can fail, right? So those kind of wires or arms that are kind of keeping the cable off the ground, that are really important for making the cable more useful for a user to actually plug into the car, those things can break, and it doesn't look great when you see those wires and cables laying around. The charger might work great, and all the codes reading back to the CPO might say everything's fine, but there's all these cables laying around that are actually holding up the main cable to charge your car, and it just doesn't look great. It opens up for kind of vandalism and other things if the site isn't being well kept. And for things that are kind of behind the scenes, with the switchgear, things can happen with that. It doesn't happen often, but you can have a main circuit breaker that trips. You can have breakers that fail. You can have impacts. You can have squirrels that get in it, birds that make nests, snakes that get into it that can maybe chew on things or cause short circuits that, the charger might look great. It might have no issues, but it actually could have something very critically wrong behind the scenes. I will bring up something with the screens, because this is something that, living in the desert Southwest, it is something that I always have issues with, is the screens are just out in the bright sun. And this is like an electronic device. Like, imagine your cell phone screen just baking in the sun for 10 years, right? It's not going to be great. So having some sort of screen that's in front of it that you could roll up, and this is from Redbox. This is like outside of a Walgreens by my house, I think. And these kind of help to keep the sun off of that. And these can be a little bit cumbersome, right? Because you have to kind of pull it up to be able to see what's going on, but at least helps from a longevity standpoint. Drew, I'm not sure if you would ever have an opinion on this, but I think it would at least help with some of the damage that happens to those screens.
Yeah, I think in certain climates, it probably does make sense. In others, it likely is less relevant.
And in the Northeast by you, it's probably not going to be as big of a deal.
Right. Screens are an interesting topic, though, because in a lot of ways, they don't necessarily have a long future in terms of being relevant to the charging session. And in some cases really aren't even relevant today. I mean, look at how Tesla does their charging, right? There's
exactly.
No screen involved. Almost everyone else has a screen, by the way. But there are going to be other use cases, advertising, other things that people want to do potentially with charging that I think will keep screens around for a while. But the screen protector in hot weather is an interesting one. I have to call you out. I didn't realize that there were still, DVD sharing services live. I got to check my Blockbuster stock and see how that's doing.
Yeah, they for some reason still exist. I'm not sure even who uses those red boxes. But no, you bring up a good point about the screens too. Just what's the longevity of them? Because like you see gas pumps, right? Which most people are used to. They have screens, but mostly they play those annoying ads while you're trying to fill up, a vehicle, which drive me nuts. But I know people always are exploring different revenue streams in the EV charging space, especially in the public space, right? Is how they can get additional revenue streams. So that is one way that people can address it, but it's also another failure point. And, Tesla, right? I have a Tesla. I get all the information on my phone, on the screen of my car. Like, I don't ever need to get anything off the charger itself, but a lot of public programs and incentives and grants require screens for public charging so they can display certain pieces of information. I think CARB in California has a certain requirement for the screen that displays certain pieces of information. So you're saying with some of these Tesla V4 supercharger dispensers that are coming online, have a little mini screen there. It's kind of pathetic. I'm not sure if that's ADA compliant at all, but it's there giving some of those pieces of information like energy dispensed and stuff. But eventually, I think you and I agree. I think if screens are probably going to just go away, because the car is going to be able to display to you everything that you're going to need to know, and then it's just another failure point. And I think there's other ways that people could do advertising through like a standalone screen or something else, or static billboards that still get you the revenue that you need, but then it's a separate piece of equipment that's separate from the charger that is, the critical piece of equipment that you're using to draw your customers into a specific area.
Right. That's exactly right. And there's probably a little bit of a different glide path trajectory on where screens go for public facing charging versus, private depot charging, which will be an increasing percentage of chargers out there. But yeah, I don't think the outlook is particularly positive on the longevity of screens. The other thing that I'll note is, I like your comment about the screens, even if you're going to do advertising or something, kind of being units that are parallel to charging equipment, but not actually integrated. Because, in the case of chargers today, a lot of the time, if a screen is blacked out, the charger is actually still fully functional if you know what you're doing and how to operate the charger. But it tends to give the impression that a charger is out of service. And frankly, if you don't really know how to start it yourself, you're probably kind of out of luck without the screen anyway. But if you remove the screen and put it off to the side and make it not part of the charger, if it's blacked out, so be it. Charging goes on.
Yep. And then kind of going back to the point on credit card readers. So I think that's another kind of appendage, if I will, that I think we're kind of like currently required to do for grant programs, state of California, places like that for public charging. But I don't see that necessarily being a thing in the future with ISO 15118 authentication. And then also, you kind of can currently do it with Mac ID. That's what you see with EVgo doing with auto charge. That there's ways to authenticate a transaction that kind of goes right to your bank account or credit card, debit card, whatever you want, so that you don't need to actually have a physical card. Because those NIAX readers, Pater, they're just horrible. They have horrible connection. It's crazy. Like, they work in every other facet of life. You could be in the, like I was in Morocco in like this desert environment away from, like, literally in the Sahara Desert. I was able to use a credit card, beep, authenticated transaction, 2 minutes. And then I'm in downtown Phoenix, Arizona, trying to use a credit card reader on a DC fast charger, and it doesn't work. I'm like, it's definitely an interoperability issue with the charger. They're not as reliable, and I think those is eventually are going to go. And with recent announcements with like Ford sending out their connector to be able to allow their customers to DC fast charge on the Tesla network, they've actually made announcements that have said that they will actually be able to authenticate the transaction through the Ford Pass. So, like, as long as you're set up with your credit card and Ford Pass, all you got to do is plug it in and walk away, right? Just like a normal, if you own a Tesla, that's what you do. So I think, and it's probably going to take another 10 years, but I could see those going away. Excuse me.
Yeah. Yeah. And ultimately the main purpose behind credit card readers being required in all these programs is supporting accessibility. And that's absolutely an important piece of this puzzle. But I do think the future is not bright for the count of credit card readers that should be in this ecosystem. Because as you say, there's just so many other avenues to payment that as the rest of our digital financial lives advance as well, this is going to come along with it. Yep,
totally. And then kind of going back to the cables too, there's liquid cool cables and there's non-liquid cool cables. I'm painting a very broad stroke there for DC fast charging. The non-liquid cool cables, there's some ones coming out that are air cooled. So there's ways that they can actually achieve the cooling and maintain their UL certifications and all their safety certifications by allowing certain peaks of the amount of amps that go through the cable, even up to, I think, 500 now for a certain peak amount of time. Cables are a bit thicker. They're not as maneuverable and pliable and flexible, but then you don't have the liquid cooling, because the liquid cooling, it's a much more usable cable to the customer, but they break all the time. There's a pump that's involved. And then if that does break, it basically has to default back to the nominal rating of that cable without the liquid cooling, which is usually like 50 kW if you're lucky, maybe like 100, 200 amps. And it's just a really degraded experience. Tesla's been able to nail it. Their V2 superchargers and V1s, those were air cooled or passive cooled. The V3 and V4 are liquid cooled, with the V4 being immersion cooled. So actually that entire cable itself is cool, not just the actual DC contactor pins in the V3. But since they maintain their charging stations better than anyone, they can get away with that failure. But it is a super usable cable. My fiance has no issues plugging that one, but with the Electrify America ones, definitely a bit more of an issue. I know those are liquid cooled, but a little thicker. Not sure if you have an opinion on that, Drew, or not.
I think both probably have a place in the market. I will say, I've had to use more force on cables than I think is reasonable, for sure, in my experience as a driver. The other thing I'll toss out that's not necessarily reliability related, but is related to this cable cooling choice and the architecture thereof. I got in a situation where we were designing a site and wanted to do an overhead charger installation, coming down from above, but for light duty vehicles. So not using, the fancy devices that, charge buses from above, for instance. And the reality is that if you have a liquid cooled system in general, again, probably painting broad brushstrokes here, that's going to have a gravity element to it, or may well have a gravity element to it, that makes putting some of this stuff upside down or at 90-degree angles from how it's normally installed not an option. And so I think that's just one more reason that there's going to be some variety in the marketplace, and rightfully so, for different applications.
Yep, absolutely. And I think there's been a lot of good innovation in the space that I think, as the charging manufacturers had to put out NACS cables, J3400 and others, I think there's a lot of innovation that's being pushed on them to get better, more reliable cables that, they're not always going to be kind of the number one reason why charging stations go down in some cases in some certain areas. So I'm excited to kind of see how that works. Going next to kind of physical aspects. So similar to kind of hardware, but this is kind of more of the physical aspects of how a charging station is designed that actually can make them fail. So, a lot of times people design EV charging stations just to kind of get the cheapest, most easiest design out there that can get passed through an AHJ and get permitted. But there are a lot of intrinsic issues with doing that that can lead to certain issues. Then also other things like icing and, stall size and orientation that can be some big issues. Drew, do you want to give an overview?
Sure. So I think this category, the way I would probably describe this is these are fundamental site design and or hardware design issues that are felt very acutely by drivers, but in any digital measure of reliability, for instance, would never be seen as problems because they'd never be observed. So, CJ kind of alluded to a few of these. The first is around essentially placement of the chargers and the ability to get a cable plugged into your car. This is mostly relevant for fast chargers. I think on the L2 side, in general, cables are sufficiently long and kind of make this not an issue. Won't get into the whole cable management problem potentially there. But thankfully, you can usually also run over those connectors. They've been tested for that.
I've run over my own once or twice.
And you're still in good shape?
Yes.
Good. Okay, so you got the CJ Berg home test.
Yeah.
But on the DC fast chargers, right? Cable length is a big deal. So Tesla, I think, is pretty widely probably known as the shortest cables in the industry. Electrify America and others have a longer standard. And the driver for that is that Tesla, being a vertically integrated system, knows where the charging port is on all their cars. And so they can have a short cable that reaches exactly to that point, whereas really all the other networks have to be more flexible than that. So this whole site design to be able to plug in thing all revolves around really two variables, which are the length of the cable. Well, maybe three variables: the length of the cable, the type of vehicle charging and where the charge port may be, and where the charging unit is actually placed. And CJ will give us an example of where he likes to see those and where he doesn't like to see those.
Oh yeah, I have strong opinions on this.
Only a couple.
Only a couple.
And then the other two are really icing, right? So when we get our gas and diesel friends, maybe a hydrogen fuel cell. I don't know if you got any friends like that.
Nope.
Parking in your EV charging spot, you can't quite get there. I think the vast majority of EV drivers have probably experienced some form of this at some point. If you haven't, kudos. And the last one is really kind of related back to the first one about site design, on stall size and orientation. What is your site set up to allow as far as vehicle types? Can you do towing? Are you set up for pull through? That sort of thing that in general haven't been big issues in the industry yet, but obviously are important to the broader transport ecosystem as EVs penetrate further.
Yep. And I'll just bring up a couple pictures here. So this is an EVgo site by my house in North Phoenix. Actually, not by my house, by my old house in North Phoenix, where there are DC fast chargers in pretty much every possible area on the site. So if you're pulling into this and you have the charge port like on a Tesla on the back driver's side, where would you pull in to potentially charge the best at the fastest speed? So it would make sense probably the one in this over here, right? Because then it would kind of meet up perfect. Well, then you could pull it around your car, or you could pull in and then stretch it directly back. It just creates so much confusion, especially when, let's say you're using a DC fast charger pretty religiously nearby. Say it's your primary source of charging, and someone takes like the two spots that you know how to charge with, and then you have to do like the mental geometry. It's like that meme of that, the Rain Man guy with all the numbers flowing through. Like, how am I going to pull into my car so that this cable will reach without it being too much of an issue? And I just think these designs are garbage and they have to go. It can lead to a lot of discomfort for a customer having to plug in their car. Tesla makes it easy, right? Because, as you mentioned, integrated system, this was never an issue for them and probably never will be. But with their V4 dispensers, they are kind of making those a little bit more center biased, longer cable, so that they can accommodate more vehicles as other car manufacturers adopt J3400 NACS. And, my guess is that they're also going to Tesla's going to try to push them to put their DC or their charging port in the same location, so it's not as much of a burden. But I haven't seen that actually happen yet. That's just me guessing. And from a design standpoint, generally the best option that I've seen from actually developing these sites myself and then also experiencing them as a customer is, I call it the end zone. So it's behind the stall, center biased, so that you could pull in or back in any of the stalls, and you're going to know exactly how to plug in your car. So if you have the charge port in the back, you can back in. The charge ports in the front and either side, you can pull in, no issues. Or if you just like to back in or pull in and your charge port's on the other side of your car, generally not going to be an issue. And there's a consistency across the site. So as opposed to that EVgo site I just showed you, right, where they're all over the place, this is consistent across every single one. So it's very easy for the driver to understand exactly how they need to get into every single potential stall. This is actually in Wagon Wheel, New Mexico, which I've actually been at before. Nothing much else there, but it was a great charging stop, no issues, right? So this is stuff that I think from a design standpoint, people have to start to take into consideration. If you're going to make it a little goofy and weird, like sometimes Tesla will put their DC fast chargers at like the beginning of the stall, so you actually have to pull in as opposed to backing in, which works, but it's consistent through a majority of the site. So there's not a confusion to a customer like, well, do I need to back in or pull in, depending on which stall? It's like pretty consistent. And you're also seeing that with, towing, right? So a lot of the stalls today, they're made just like this in the end zone, or the one before with that EVgo one. There's actually no way to kind of use a trailer. So having better stall design for trailers, especially as you're starting to see more of these development around hubs start to come up in the conversation, that definitely has to be a consideration for people that do tow. Some of the Rivian Adventure Network sites usually have like one towing stall, and it's made very obvious, right? It's very clear that that's the towing stall. There's not a customer confusion of, do you back in or pull in front ways into that stall? It's like you are going to be using a trailer for it. It's very obvious. So that's one thing. And then from an icing standpoint, I remember this article I read like 3 years ago, I think. It's from Electric Tech, and they showed this little gadget that they use in China, mainland China, where it helps to prevent icing. It's actually this little block. And Drew and I, before the session, are actually talking about this unrecorded, but how this is probably a temporary solution used in like certain circumstances and instances where you're having a lot of issues with icing, that maybe this could be put in temporarily to kind of help deter those people that are maybe doing it on purpose or doing it pretty religiously in tight parking spaces, but not something that you're probably want to get, that you're going to want to have over time, because snow plows, right, could maybe plow these things up. It's another thing that might fail on site, that if this actually doesn't go down, then you actually can't charge your car. So it actually could, it could, quoting Obi-Wan Kenobi here, it could actually be the thing that it was supposed to prevent from happening, which is, having a successful charging session. So I think it has a place, but I don't think it's something that we would want to see ubiquitously permanently installed throughout all DC fast charging sites. Kind of like a way to kind of have a quick fix, just like with handicap parking. Disabled parking, right? You don't really see too many people cheating that system, at least where I live and what I've observed, right? People could have different opinions on it, but I think people, once they get the hang of you're not supposed to park here, you'll get ticketed if you do. It's not moral, it's not the right thing to do. Then they're going to stop doing it. And I think as EV adoption grows, it'll become less and less of a thing. But there always will be circumstances where I think this may come up as a potential solution.
Just a quick adder there. I mean, CJ's talked about icing because that's what the reality is most of the time today. There's also the challenge about, EVs being in the way of chargers. And I certainly won't be the only one to have seen this relatively regularly. The one comment I'll make, though, is with EVs that block chargers, it tends to be overstaying one's welcome at a charger, meaning that they're still plugged in. And the beauty of that is that market mechanisms can be relatively easily implemented to change that behavior. And we've actually started to actively see that. Like I've started to see that idle fees being implemented where they were not previously, even though they had the capability to do so. In a couple highly trafficked spots that I go through, which is awesome to see in the market maturing.
Yeah, but like those, idle fees, or, once you're past a certain state of charge, to, have you kind of get on your way. So it kind of helps to deter people from staying there too long. And, a lot of those free charging programs that the OEMs put out, or a certain amount of kilowatt hours they get for free, I think they're horrible. We could do a whole episode on that. But those kind of lead to certain behaviors like that. So as much as you can get people to kind of unplug and go is, I think, really important, because a lot of times to, continue on your road trip or continue on your day, you actually don't need that full 80 or 100%. You actually might need, 50 or even 40%. So it's really important. And that's also wasting your time, right? With currently, most charge curves start pretty high, low state of charge, and they kind of taper off. So if you like wasting your time, you could stay there longer. But I think most of us, as rational human beings, don't want to actually do that. So it's, it behooves you to stay longer at those charging stations. And then quickly, the size and orientation of the stalls. So, a lot of the developers, you kind of have like the standard, 8.5 by 19 or 9 by 19 stalls. And that's kind of what's commonly been used for passenger vehicles. But, knowing that you'll need to actually like walk between those stalls, grab a charge port, and then bring it back kind of necessitates a little bit more space, a little bit more clearance between those stalls. So having a little bit more space, if you can, and understand that does cost more money, but having more space for those stalls is actually super helpful to the customer and leads to a better customer experience, especially if there's like a big Hummer EV that's charging next to you, and then you're pulling up in your, I'd say, normal size car in the stalls like 9 feet wide. It actually might bleed onto your stall a bit. So then have to park a little bit further over, and then it just kind of cascades until potentially there's a stall that actually can't be used because everyone's kind of parked over a little bit and is kind of overflowed into another stall. So it's important to kind of know from a developer standpoint, try to make those stalls as big as you can to accommodate. I would say like not like 16-foot wide stalls, but I would say like another foot or two per stall can go a very long way from a width standpoint. So we'll talk now about planned maintenance. And this is stuff that it's not necessarily the charging station's broken, but there's things that the CPO and the charger OEM have to actually do to maintain the charger. But Drew, do you want to talk about some ways that this could potentially not be used properly by the charger OEM or the CPO that can lead to a negative customer experience?
Yeah, absolutely. So there's, kind of broadly two categories in here, right? There's some planned maintenance that'll be inspections and or maintenance of the actual hardware itself. And there's other that I'll toss under the category of kind of generically software upgrades, if you will, that's mostly over the air, but could be on site as well. And I think that we have in the past seen whole sites getting shut down for either of these things, whether it's a person there on site or upgrading an entire site over the air at the same time. That practice obviously doesn't work well for customers because you have whole sites going offline. That's been largely changed. So, CJ will talk about examples of this. You tend to see a technician out there kind of, working left to right across the 8 chargers going down the line for his day. You never have more than 1 or 2 offline at any given time. And that's not really a big deal. And they can do the same thing with over-the-air updates. But the bigger challenge, I think, is sometimes when software upgrades in particular are being rolled out. We've seen instances of very poor coordination across a whole corridor or even a region, right? Where you just say, I-90 across New York, all 8 major sites are just offline because they're all doing some software upgrade that, might be the best thing since sliced bread, but, do it one day on one and the next day on another, So I think getting just plans together better is an important piece here. I don't think there's that much more to it. I think it's just figuring out, when you think about a reliability issue, it's always about likelihood of the issue and the impact of that issue. And in this case, it's a planned event, so the likelihood's 100%. It's just about mitigating the impact, and that's about spreading it and communicating about it. I think communications probably could be a little bit better through nav systems, apps, and otherwise. But I think this is all headed in the right direction.
Yeah, I think there's a lot better communication that's going on. I think it could be better, like even having as you're on a road trip or navigating to a DC fast charger, your charger's preconditioning, it just kind of has a little pop up on your screen. FYI, one of our technicians might be out there, but no worries. You have a charger available, right? Something that's like that. So it's okay, understand I might see a guy there, but nothing to worry about. Or even something that's just like that, that's even dumbed down even more for us general Americans that are driving these. I think there's a way to communicate that. I've been at Tesla sites in the middle of nowhere where a technician's working on one charger, right? And one dispenser, or he's kind of behind the scenes, behind that fence, dealing with the rectifiers, the power cabinets themselves, or the switch gear. And it's kind of really, it doesn't really degrade any of the experiences. Maybe one port's down, but it's very clearly identified. There's a cone out or something that don't pull into the spot because it's not going to work. Also, on a weird side note, if you ever want to have be thanked for your job more than anything in the world, be one of those people, because every time you pull up to those, I think 17 people, everyone that stops says thank you, and to those technicians to the point where they're almost annoyed. So that's something if you ever want to experience, and get into the EV charging maintenance space, everyone will always love you, no matter what. But yeah, just don't take down the whole site. Go one by one. Communicate very well what you're doing, and have an eye towards the customer experience. Obviously, we don't want technicians doing things hot while people are charging. Totally get that, but there are ways that you can work on pieces of equipment. I would say probably 80 to 90% of the time without taking down the whole site. And Drew, as you were mentioning, don't take down a whole corridor. There's no need to do that. A lot of these preventive maintenance items are changing filters or replacing basic components that are almost like a photocopier, which probably people below our generations don't know what those are, but very user-friendly in how to replace a certain port, pop it back in, make a connection, boom, you're good to go. They're very easy nowadays to repair and maintain. So it can be done with a little bit better communication, overall coordination. Next to electricity supply, and this probably goes without saying, but the power does go out sometimes. And this can take down, obviously, a whole array of chargers. And it's not necessarily the CPO's fault, but I think they do have a role in trying to communicate when this does happen so people don't have an issue. I think we in our homes, we have power outages. We understand those happen sometimes without notice, and they can be very annoying. There are ways you can put in on-site generation and backup supplies. But Drew, I know you've run the economics on it. I have too. It's not really in the money to like put these things in it necessarily right now. Some people might make the argument there's ways you can pencil whip a spreadsheet, 15 different ways to get it to work, but it's a very difficult business case to make today. But I think there will be more integration of this in the future to help from a resiliency standpoint, peak shaving from demand charges, from electric utility rates, and also being able to kind of play into energy markets as well. This is stuff that's all in the future. I don't think is super near term, but you do see instances of EV charging companies that have deployed backup charging. But I don't think it's really for resiliency. It's more to kind of reduce demand charges. I'm not sure if you've seen stuff similar.
That's right. Yeah, most of the deployments today, I'd say, of energy storage related to EV charging fall in one of two categories. One being demand charge mitigation, so just limiting your peak, and the other, I guess, maybe kind of a sibling of that, which is your site does not have enough interconnected capacity with the utility, and so you want to amp that up to be able to give drivers the fast charging experience they want, even though you don't really have the power connection. So like FreeWire is a good example of a piece of technology that has a niche in the market for serving that need. But I think the resiliency or reliability aspect of it, to be candid, I spend the other part of my life that's not in the EV world doing resiliency work for electric utilities. So we are blessed in the United States with quite high reliability of our power system. And that comes with a lot of hard work from a lot of people. But there are parts of the country in particular that are more prone to these power outages, and there will be a better case for, spending capital to provide resiliency to these assets. Look at the leading penetration market of EVs, in California, right? There are some areas of California that are increasingly prone to proactive power shutoffs to avoid wildfire risk, right? Or to mitigate wildfire risk. And so I guess one of the things to think about in this space is understanding your site that you're building and what its reliability risk is. There is a way to differentiate better than whatever the utility-wide statistics are. You can understand that a lot better, particularly with respect to things like proactive power shutoffs for wildfire risk is a very specific example. But overall, for most sites, this is not an area that you're going to do anything specific about. But as an industry collectively, it's going to be thought about, but probably more handled by electric utilities, to be completely honest, in their responsibility to serve this sector and serve the public.
Yeah, like if you look at the safety metrics and stuff for most utilities, it's not horrible. It's like minutes per year. But obviously, we as human beings, we'll experience those, and it's like pretty cataclysmic, right? Because most of our lives now revolve around the usage of electricity, and now that our cars are involved in that too, it can be pretty detrimental if the power does go out for an extended period of time. In SAIDI and safety meetings, system average interruption frequency index and SAIDI safety. The one's duration, the other one's frequency, and the other ones, I think KD is customer centric, not just Google them. I used to go through a lot of those when I was at the utility, but it's stuff that I think is going to be more kind of solved with the utility. And honestly, anytime you're building a site that's in a very unreliable area, the site host is probably going to tell you. You're probably going to know from the local electrician. Like you'll get so many triggers early on in the project that like, hey, just FYI, you might have an issue here, that you can start to plan for other, maybe having quick connects for a mobile battery to connect, or a diesel generator, even though we don't want to potentially use diesel to power electric vehicles. But there's ways you can address it in a very light CapEx way if you think it's going to be an issue. But I think in general, it's going to be kind of working with your utility on that one.
Yeah, and just to put a very brief quantitative cap on this topic to make sure we all understand really how how tight this reliability of the power supply is. The best utilities in the country right now are delivering SAIDI, so average duration of an outage, or average duration for a particular customer in a given year of under 50 minutes, so less than an hour, which is really quite incredible, and an average interruption of about a half. So you'll experience a power outage every 2 years. So if EV charging were as reliable, so I did do a little math back of the envelope on this. If EV charging were as reliable as the US power system, the average driver would expect to have a couple, literally like 1 to 3 failed charging attempts in an entire lifetime of driving a car. So, for those of you that have been an EV driver and have experienced some of these things, I mean, just think about fundamentally how different that level of reliability would be. And that is something that has been achieved in a much more complicated, in many ways, industry, right?
Yep. The most complicated machine that humanity's ever built is the Eastern Power Grid in PJM. But most people don't know that. So if we're able to achieve it there, it's like, honestly, EV charging is so unreliable today due to all the issues that we've talked about, that this is probably going to be the least of your issues. So it's probably not one that you need to worry about as much. Honestly, it's probably going to be the other copious amounts of things that can go wrong. All right, going to weather, which is probably front of news. This we're filming this in February 2024. There's been a lot of news recently about what happened in Chicago with the EV apocalypse that happened there. I mean, just look at the different headlines from both left and right wing media sources on this, and weather can have an impact on whether or not you can get a successful charging session at a DC fast charger. And there's obviously things that you can do, and we can talk about that, like how to precondition your car. But there's actually a lot of ways that, from a site perspective, if you're not thinking about weather, you can actually have a significant amount of issues. Drew, do you want to expand on that?
Yeah. So the 3 that I think we'll talk on briefly here are probably the most publicized, but there are others. Top of the list is extreme cold weather performance of EVs in general, but in this case, we're talking about the charging experience. So there's a difference in performance, and there's some challenges with it, both on the vehicle side and the charger side in very cold weather in particular. I will note that there could easily be some hot weather challenges as well, cooling and the like, but that tends to get less press than people being excited about Arctic blasts coming through places like Chicago. So talk a little bit about that. The other 2, one could actually cause damage to the charging site, and also customer interruption. That's flooding, and CJ's got a nice graphic for that. Look at your flood maps. Make sure you know where you're putting your chargers. And the other that can cause plenty of customer inconvenience, probably rarely charger damage, is snow movement and keeping snow clear from in front of chargers. When in the era of chargers getting installed in kind of back corners of parking lots, they've often been victims of snowbanks when they're not well utilized by the public. But I think that's in general changing. But hand it back to you, CJ.
Yeah, no, this kind of really comes down from a site design perspective. Understand where you're building, work with your civil engineer pretty closely if you are in an area that is prone to flooding. Make sure you design your site with moving large amounts of water very quickly in mind. And this isn't something that really takes like a rocket scientist to do. FEMA in the US puts out these maps. So that flooded charger picture I showed you is actually at this gas station in Quartzsite, Arizona. And you can see it's actually in a flood zone. So it's not surprising that it flooded. It sounds that simple, but Quartzsite itself is in most of the city is in a flood zone, so it's kind of an issue. But there are ways you can design a site to have more extreme grades to move the water away from a charger. Putting charger pads a little bit higher above the grade, right? Making those pads a little bit beefier. There's obviously going to be issues with ADA and stuff, but there's ways you can work around it. really working with offsite grading to try to create barriers to get water from flowing away from the charging stations, and understanding that this is all increased cost. But I think we can all agree as a civilization that we don't want to see this happen a lot, because this can obviously creates very negative imagery. People, we don't want people standing in puddles while plugging in chargers, even though it's going to be generally safe as long as you're not doing things in a very unsafe manner but you don't want to do this, right? So I have seen some DC fast chargers where they actually do put the pad above grade, and I'll actually add that in post production. I'll show it on the screen, but this charger that I'm showing on the screen is actually in Oklahoma, or was it Omaha, Nebraska, and it is in a flood zone. And actually put it like 3 feet above grade to kind of keep the switchgear out of the flood zone, which is pretty cool. But yeah, this is stuff that really can be thought about in the design process. Obviously, I don't live in a snowy environment, but if you do, you got to be able to put the snow somewhere, right? People are going to be plowing that parking lot. It's in your site host agreement that they have to maintain that parking lot. They can't just plow everything but your EV charging stalls, right? So you got to think about where you're putting that snow rule on your sites. And actually, most AHJs in those northern climates, like Drew up by you in New York, like they're actually going to want to see where the snow zones are on your property. And sometimes at like very nice grassy knoll area where you want to put your chargers, it would work perfectly. Sometimes it's actually designated for snow removal. So you actually might not be able to put it there, and you might not find out until very late in the process that that's what that area was actually used for. So it can definitely be an issue. I think it can be addressed. And then going back to the chargers themselves, because they do fit. I mean, there's been so many times. I mean, there's been videos made about being like -20 or -30 out, and the chargers fail. But gas pumps work. So I'm kind of at the point where I think we need to push the charger OEMs in the right direction. So, with UL 2202, UL 2231-1 and 2, trying to push those metrics a little bit further to have internal heating elements to try to keep these stations online. I'm not going to pretend that I know how to build these charging stations, the actual chargers themselves better, but I think we have to think a little bit better about how we can actually push these further and further. I think there's, certain temperatures that reach in North America like to -70 Fahrenheit. So it's like, well, how can we make sure that our chargers can work to around there? I'm not saying that every charger has to be installed and operate to that, but like, what are some add-ons that could be used to get us to have those charging stations operate reliably when it does hit those temperatures? All right, so we've kind of talked about the 8 kind of ways that charging stations can fail, and we'll talk about perceived versus actual reliability, and because there's a lot of things that an uneducated EV driver might think of as a reliability issue, but actually isn't a reliability issue. It's actually not the charging station operator's fault or anything like that. It's actually something that goes kind of above and beyond, or is actually their fault as the driver. Drew, do you want to talk about some of these instances?
Yeah, so I would say what we'll talk about mostly is perceived reliability issues due to lower than expected speed. And there's a whole bunch of reasons for that. I will say that there's probably also some perceived reliability issues where it is truly just user error in understanding how to initiate a charging session, payment things, stuff like that. The caveat there is that, a well-designed system should have that sort of user experience extremely infrequently. So in large part, that is probably really on the design of the system, not on the customer. But in the case of charging speed, this is one where I think the vast majority of charging networks, if you poke around, will have gotten flack at many of their stations at one point or another by drivers that see, 100 kilowatts or 350 kilowatts or whatever Tesla 250, whatever the rated speed of a charger is, they see advertised to them. And then they go and, the thing's rated for 150 and they're pulling an average of like 60 over their charging session. And they say, like, what gives? And that's a reasonable reaction, right? Without further information. And this is really impacted by a few things. One is just straight up misinterpretation of what your car could possibly do. So I won't dive into it, but every vehicle has a charging curve that is essentially under certain conditions, primarily state of charge, but other conditions as well. There's a maximum rate of putting energy into your battery is generally the way to think about it. And if your car can only accept 70, it doesn't really matter if the charger can give 150, you're going to get 70. So that's first, and that's just an understanding of the technology thing that will take time for people to learn in some form or fashion. And it'll probably never be learned in the concept of a charging curve. I don't suggest we start advertising that to customers.
No.
The related to that is kind of just the expectation between the 150 being written on the sticker there and then whatever it says it's giving to you. The other bit is variables that impact the speed that make it really hard to understand, even if after you've gotten used to your car, let's say you buy your car and the first time you go to charge it at a fast charger, you go and you're like, that's not really the speed. Then you learn a little bit about it. You say, okay, my car kind of only can do like 70 kilowatts when it's kind of half charged or whatever the case may be. It just gets more complicated than that because of, in particular, temperature, but age of the battery and its degraded state, other things that can impact that charge curve in ways that are not always intuitively obvious. I'll say I usually think I understand what my car is doing and capable of. But even I, who watch this pretty vigilantly, because that's who I am, sometimes you get a performance that's a little bit unexplainable without further data. And that can be very frustrating. And the other one to throw out here is site level power sharing. So different charging system architectures are designed in different ways to share power across chargers. Some don't do any sharing, some do a lot of sharing. Like Tesla's standard architecture, for instance, is for their V3 at least. It's 4 charging plugs across what is it? 387 kVA, I think the block is. And so they each have a max of 250, but once you have 2 cars there, you can't get 250 on 2 cars at once, right? And you get 4 cars there, you're going to be getting under 100 on average each, right? And there's also a version of that goes up to the site level that's not specific to the particular power cabinet. And that's typically very opaque to drivers. And if that's not communicated in some way, could be quite frustrating. But again, is not really foundationally a reliability issue that's solvable. So I think the takeaway here is all of these things are about communication and learning by the collective populace. And there's things that CPOs and auto OEMs and others involved can do to aid in this process. But this is more a learning than a solving a reliability problem issue.
Yep, like having an expired credit card in your system to try to authenticate a transaction isn't the CPO's fault that you forgot to change your credit card, right? Like, that's stuff that just comes back on the customer. But I think the more that we can communicate these to the customer, if there is site level power sharing going on, having that come up on the customer screen or pre-warn them as they are approaching that charger, like, hey, FY, you might see some degraded performance due to, good, basic, average American explanation of what's going on, right? Play to the lowest common denominator so that, there's a basic understanding of what's going on so people aren't confused or frustrated. Because I'm the same way, Drew. It's like sometimes I pulled up, I'm like, this should be working just fine. It's, the battery's preconditioned. Like, I'm at a low state of charge. This is great. But like something else is going on and it's not being communicated to me. So I'm just sitting there kind of perplexed of what's going on. And I could just think it's potentially something going on with the charger, but it actually could be that Tesla's participating in some DR event in California that they're getting paid oodles of dollars to do, right? If they just tell me that, I don't care, right? As much. I mean, I might be a little kerfluffled, but it's going to be whatever. But I think that's stuff that, not to say that everything is always the CPO or the charging OEM's fault. There is some stuff that is actually the customer's responsibility to kind of know. I think that's going to be better and better. It's going to get better and better over time as there's better education, as we get more drivers on the road that are more familiar with this as well. Reliability measurements. So there's different ways that EV charging is measured. And it's not always universal. It's not like in the power system. Drew and I both come from like more of the utility power system space. And It's not like how it works in power. It's completely different. It's very bespoke. It's very balkanized. It's not really universal. Drew, do you want to talk about kind of how this works and kind of some of the pitfalls and maybe kind of where we're going to kind of help better define reliability metrics and measurements in the future?
Yeah. So, in today's EV charging market, reliability reporting is really done for two reasons. The first is networks trying to understand their own performance and publishing what usually are glowing reliability figures that are referring to something. It's just not a total picture of reliability. The second, and probably the primary driver, is reporting related to incentive programs, right? The vast majority of at least non-Tesla installed fast chargers in the US are really the result of some form of incentive program. And most of those programs have reliability reporting requirements of some kind. They do vary, but the theme of how it's done is that those reliability metrics are simple in nature, focus on what is easily measured, and that kind of by definition misses a whole bunch of the things that CJ and I talked about here today that definitively cause bad customer experiences but don't easily show up in data. So the reliability metrics often focus on, how often the station is online, in the sense that like the network is up and can see that the station is live. But as we've talked about, there's like 17 other things that might be in the way of a driver actually being able to use that charger. The metrics may look at things like failed attempts to charge. And that's a really good thing to look at. But again, not telling the full story. So I think, I'll take a shot at, some of the things where I think this is going. CJ could probably talk about this a bit too. NEVI's got some rules in it. In general, there's kind of a 97% uptime guarantee or requirement within the NEVI programs. And it's going in the right direction, right? It's adding some onus for reliability. We have seen some states' implementation of NEVI programs that have done positive things, like pushing at least some portion of the incentive funding to be spread out over several years, dependent on reliability performance. I, for one, think it's highly unlikely that any of these companies will not end up getting paid their full amount because of reliability issues, because the definitions are just pretty loose. But it's a good thing to see. I think as we move forward, though, the industry needs to come together to define reliability in a way that sees the whole customer experience and can bring that into a measure. And it's complicated, but there are material improvements that could be made over how we do it today. And I think you're going to see this first, honestly, from some folks like fleet providers, where they're going to dig into all the stuff that's going on with their fleet, and really understand what true reliability and customer experience they're getting. I think it may happen there before it really flows to the public. But there's a whole bunch of things to look at. Looking at count of charge initiation attempts compared to actual lasting sessions is a really good measure that's often not really looked at in any reporting today. Frequency and the depth of derated periods is important. Understanding like how often is this thing actually at full strength, if you will. Looking where charge sessions end prematurely. I had an experience with a rented Polestar in Texas earlier this year at an EA station where the session would like start and I would like go into the Walmart and start poking around, and like 5 minutes later it would like stop, and what gives? And I did that like 5 times to charge this car. Stuff like that happens. So you can look at that in the data. Understanding when the driver doesn't even try to initiate a charge. This one's tricky to do, but is really important because there's other stuff going on, like we've talked about, that's not necessarily going to be in that core session data that we all like to look at. And there's ways to do this in very simple ways that don't necessarily definitively say what went wrong. But for instance, looking at a bank of like 4 or 8 chargers, right? If you see that the 4 chargers, on average, each charger gets used 5 times a day, and one of those 4 hasn't been used in a month, like something's wrong with that charger. That's not just a unlikely thing to have happened, right? And so incorporating things like that into metrics to understand your charging assets is important. And I think there's also things to do on understanding waiting periods as a proxy for availability. Because waiting is not necessarily part of reliability, but it's part of this whole customer experience that needs to come together. So I'm really excited about some work that we're doing in this space to bring together this customer reliability experience measure, and excited to see what others are doing as well.
Yeah, it's a very complex topic. It's very simple in some ways, but it's like very nefariously like complex if you really dig into the nitty gritty. And I think, at least from my perspective, I've kind of seen a lot of the CPOs they kind of build their own metrics sometimes, and it's kind of like, I always use the analogy. It's like the prisoner building his jail cell, his or her jail cell, and it's like, obviously that's going to be gamed, right? And I think they're always going to want to show, as you were talking about, they always show glowing reliability, but we all know as customers and users of this infrastructure that it's actually not as reliable as they say they are. A lot of it's going to be and also a lot of it's driven by incentive programs, and a lot of these people at these agencies aren't reliability experts. They're just, sometimes in these government agencies, and nothing against them, they're doing the best that they possibly can, but they actually are not putting out good reliability standards. I think Nebi did a good job at 97% uptime on an 87-60 basis, and everyone in the energy industry will know what that means. But on a days basis, that's like 10.95 days a year that the charging station's offline. I don't think that's not great, right? You have so much leeway in there of things going down, I think, and really affecting a customer experience. Like if the power system, Drew, if there was an outage, like of a duration of like 11 days a year, like I know South Africa has issues like that, but most of the developed world, that would be unheard of from a power system reliability standpoint. So I think it has to kind of get to some sort of that level or close to that level, not 97%, right? I don't think that's really checking the box, unfortunately. And yeah, I think in the future, I think, you and I have kind of talked offline about like, wouldn't it be great if like NERC would just like oversee this, because like big, scary federal 4-letter acronyms of companies, the National Electric Reliability Council, our corporation, like they would come down like heavy-handed, right? But at the same time, that might not, I don't think regulation is always the best way out of these things. But that sort of kind of reliability oversight, I think, wouldn't necessarily be the worst thing in the world for this industry to kind of maintain certain metrics.
Yeah, and on that note, I guess I would add that figuring out how to better quantify and measure reliability across all these issues and boil that up to a customer experience, whether you go down the path of the industry being more regulated, which I think in some markets is very possible and others very unlikely, or you believe in competition is just eventually going to fix all of this, it matters, because if you can measure that, go the competition, go the regulation route, then you can reward and punish. The competition route, if you know how to measure this stuff, that makes it a lot easier to value the different services differently. Whereas when it's a little bit hazy, for instance, the valuation of these charging companies, if no one's really got a good eye on what the difference in reliability is, how do you say that makes us, worth more? Until that really flows back from customer, revenues and results, and that may take time. So, there's good reasons to work this out, regardless of what you believe in on the, regulation versus competitive pressures viewpoint.
Absolutely. And I think we're about to start seeing that as more customers are going to have access to the Tesla Supercharger network. We're actually going to have, I think a lot of customers are going to be voting with their feet here. on kind of what chargers that they think are best. And, kind of historically, folks that had CCS cars in North America were kind of handcuffed to using, pretty much Electrify America, EVgo, and a sporadic number of other networks kind of throughout the country. And now they're going to be able to use the most reliable network in the world. And I think that's really going to put a lot of pressure on those, I would say, CCS OEMs to really kind of step up the game. And regardless if they are showing a glowing reliability figure, customers will vote based on their experiences of what network that they're going to use. And I think that competitive pressure is going to be very helpful to kind of push the industry forward. And some of them might fall out. So, there might not be, not everyone may make it through this transition, but I think it's only going to be better for the customer the more options that are available.
That's right. And on a related note to, to the Tesla network becoming more available, so increasing, just competition of it no longer being, this is the only charger for 50 miles, doesn't matter what network. Pricing is going to start coming into play. And I'll leave that for another day. It's worthy of another conversation. But we're going to start seeing how elastic prices are and who cares to pay more or less, and how that may be related to reliability. So look for more in that space.
Oh yeah. That's like, in wholesale power markets, if you're like the generator that wields market power, you can put whatever price you want on the power you sell into the wholesale markets. It's like that stuff. But let's talk now about kind of who is responsible for a lot of this. So, both Drew and I was a former management consultant. Drew is a current one. We cannot get away from a conversation without bringing up a nice PowerPoint responsibility matrix. This is part of our DNA. So what we have here on the top is kind of all the different I'd say players in this space, very condensed, painted a broad stroke. And then on the left-hand side, going down, we have, the downtime reasons that we were talking about. We kind of just took a swag at, who's responsible for what. And I think one of the things I want to draw everyone's attention to is that there is a huge importance and role for the CPO in every single one of these categories. They are kind of the one throat to choke when it comes to a lot of this. So a lot of these things that we've talked about, almost every aspect of that can fall back on the owner, the CPO of these charging stations. And there's also some things too, like I want to call it, like having the site host. They're kind of usually seen in the development space. If you're working with the site host, you usually try to sell them on like, hey, you're not going to do anything. These are going to sit in the corner of your parking lot. It'll be great. You'll get a nice monthly rent payment and everything's, hunky dory. But they actually have to do certain things to maintain that site on your behalf. So it's really important that they're also engaged in this process, and they do have some responsibility here. Drew, any kind of key takeaways that you want to bring out of this for the viewers?
No, I think those are good ones, CJ. We could go through all of these, but an interesting one, I think, when you kind of step back from this, is to see only one X in the electric utility column, and that's a little bit fascinating, right? Because they're the supplier of all the power that's going through this thing, and yet a very small piece of the reliability puzzle. And that's because they're a extremely reliable industry to look up to for the EV charging industry. And the other thing I'd mention on that note is that, I think electric utilities nationwide are still finding their feet on what their role will be ultimately in the EV charging space. You see that through a whole bunch of different kinds of pilot programs nationwide. So that's a space to watch, because there are certainly some markets where the electric utility will end up playing more of a role in reliability of the EV charging sector generally, in one way, shape, or form.
Yep. All right. So I think we've talked all of the viewers' ears off at this point. I think I just want to thank everyone who's made this far in the video. You are a trooper. Drew, I want to thank you for your very gracious amounts of time going into this. I think we've talked about a lot of key topics that hopefully will open up some good conversation for the industry, and really start to kind of push the industry forward, and kind of knowing how to address some of the reasons why these charging stations can fail. and really help our customers, especially as we're kind of going out of the early adopters into, you know, the early majority, late majority, hopefully at one point in time in the EV charging or in the vehicle space. So we really want to get this right. We really want people to have good experiences. And it really all starts with all the folks in the industry doing everything that they can to address these on the front end.
Absolutely. Yeah. Appreciate you having me, CJ. It's been a pleasure. And for anyone who's looking to continue the conversation on reliability, I think both of our lines are always open. And myself and my team here at PA would be more than happy to chat as you're working through these issues yourselves.
Yep, I'll drop our contact information in the description, so feel free to reach out to either of us. Happy to go into the weeds on this. I think we're both EV nerds at this point, and we love this. So happy to extend the conversation further. Also, if you like this content, please like and subscribe. Comment on this. We're happy to include all of you guys in the conversation as much as we can. And that's it. Thank you all.